Hello everyone, my name is Kristaps, and during the last couple of years I have been dealing a lot with WebSockets, building Apple TV application and helping to maintain one of the well-known library of Starscream for WebSockets. So let's talk about WebSockets. And quickly before I start, I would like to tell about myself. I'm a Swift developer, making apps and solutions for all Apple platforms. And I love open source and help to maintain Starscream WebSocket library, also multiple Rx Swift community-based frameworks and libraries, and helping out GraphQL Apollo SDK. I'm co-contributor at Swift Weekly Brief with my good friend Bas Brook. Sadly, this year I cannot give out any stickers. But if you don't know what's Swift Weekly Brief, we are delivering news about what's happening in Swift, open source Swift, right to your inbox every second week. And let me start this presentation with a small story. This is my cat, his name is Mr. Byte. Although we can call him Kilobyte or Megabyte now, as he's much bigger. And WebSockets and sockets in general are data streams where you can send chunks of data back and forth. So it's like Mr. Byte running and picking up his toys and running back quickly. And today our plan is to talk about WebSockets, what is this technology, and how you can use it, how does it work. Then we'll check how we can use WebSockets on Apple platforms. Then we'll take a look at small demo and talk about pros and cons about this technology. But what are WebSockets? It is kind of passing notes using this string telephone where you have two cups on both ends. So when one side is talking, then other side needs to listen and vice versa. And why we need to care about WebSockets and where it is used. One of the best examples is chat applications. So when you send or receive notifications, you want to be notified right away about these messages. Another thing is real-time applications. So let's say now you're delivering food with contactless delivery, and you want to know exactly when the delivery person has left the food right at your doorstep, because you want to enjoy it while it's still warm. The stock market is next example, a really huge one, where every nanosecond counts. You want to buy or sell share before someone else does. Gaming, of course, is a big field as well. For instance, online gaming and also sports scores. The web was built around the concept where client, essentially, which is a web browser, just requests data from the server. So basically, you as a client, you describe what you want, then you open connection, and then the server processes the request and sends back the response. So basically the server work is just to fulfill these requests. And this was fine back in early days, but now web is more dynamic. And things started to get more interested roughly around 2005, when Microsoft came out with the idea about Ajax, where folks back then started to explore this bi-directional communication between client and the server. And sadly, back then, no solution was standardized or good enough or widespread. And one of the most popular approaches, even nowadays, is long polling. It involves that HTTP connection stays open between creating the request and giving a response from the server. So it's quite a well-known technology, but the thing is that there are a couple of downsides. So because every time you're making the HTTP request, you're setting the cookies and headers, and in most of the cases, cookies and headers aren't needed to fulfill some of the requests. But what in fact we need is a connection between the client and the server. And most importantly, it should be persistent. So this is where exactly WebSockets shine. In essence, WebSockets isn't a breakthrough innovation. It's just two things brilliantly put together. So those two things are HTTP requests and TCP IP sockets. And around middle of 2008, pain and some limitations irritated two developers, Michael Carter and Ian Hickson. So using IRC and a couple of mailing lists, they put together a idea about this modern, real-time bidirectional communication on the web. So this is how WebSockets idea was born. An idea was standardized in 2010 and put together in RFC 6455 WebSocket standard protocol. And actually, same year, Google Chrome version 4 released WebSocket support. A couple of years later, 2013, iOS and Android browsers made support for WebSockets as well. And now we can tell that WebSockets are very good supported in any web browser, and support is generally very good. So what are WebSockets? So here's the definition from Wikipedia. So WebSocket is a computer communications protocol providing full duplex communication channel or a single TCP connection. So let's break it down. So WebSockets allow extremely fast two-way networking communication. So it's faster to receive and send updates between client and server. And it is connection which persists over time. So you don't need to open new connection when you want to request data from the other side, let's say from the client, from the server. And it reduces a lot the latency. So our apps are in general faster. And security is a huge topic as well. And I want to mention that WebSockets are secure. It works with TLS encryption and often referred to SSL. So WebSockets are secure. And I want to mention that everything what I'm talking during this presentation is written in RFC 6455 WebSocket standard protocol, and it goes in depth in every detail about WebSockets, although there isn't explained about technical implementation. And WebSockets are built on top of TCP stack, so that means that client and server, they need to agree how the communication is going on, what's the process. So there are a couple of things to keep in mind, and several steps involved, like initial HTTP request, then actually agreeing to make the connection, then sending and receiving the data, keeping connection alive, and then in the end, closing the connection. So let's talk about each of these steps. So first one is connection handshake. So when client wants to establish a WebSocket connection, the server, it's making the initial GET request and setting the upgrade header. So that means that you are informing the server, hey, I want to open the WebSocket connection. And the server processes everything, and if it supports the WebSocket protocol, the connection, then it sends back the response, yes, we can upgrade to the WebSocket, and now we can communicate over it. And let's check out this animation where client makes the initial request, then the server understands, okay, everything is fine, I can open the WebSocket connection, then the WebSocket connection between client and server has been opened, and both sides can communicate with messages over time. And communication is really important part in WebSockets, how client and server, they both can send and receive messages over time. So it's quite a complicated process. and then the framing is not that easy. And here's the picture where you can see how the WebSocket frame one message looks like. And let's break it down by each of these smaller details. So first one is control byte. So it means that fin, this one bit, indicates that this WebSocket message is final. Usually, most of the time, the messages just fit in one WebSocket message. But if you want to send bigger file, let's say, then you need to split apart. Then there are a couple of reserved bits. And next one is opcode or operational code, which basically describes what this frame represents. Either it continues, either you want to send text or binary data, or you want to terminate the connection, or ping or pong. And mask just simply tells that whether this message should be encoded. And usually that's the case you want to do. So we need to set it to 1. And payload length describes how big is the data you are trying to send. So basically when to stop reading from the stream. And masking key, it's used to ensure that bad proxies cannot abuse or any attackers in the bill. And payload is actual data, what we want to send to the other side, and what's the length? It was from the payload length field. So basically when we need to stop reading from the stream. And ping and pong is another big part of WebSockets. So its ability for client, for instance, to tell, hey server, I'm still here. I haven't sent any messages in a while, but I'm still around, so don't close the connection just yet. So in other words, it's called heart beating. And opening and keeping connection isn't just one task. So there is closing connection, which is really important role. So when we want to close the connection or something has happened with the connection itself, we need to inform other side, hey, the connection has been closed, let's close it properly. Otherwise, if you don't do it, then there can be really serious issues like memory leaks, server overworking, like sending messages out to the void when client doesn't receive anything anymore, or even data corruption. So trust me, I have had these issues before myself, and it's really, really hard to debug these ones and pinpoint the issue. And let's make a small recap what we have talked till now. WebSockets is the way to send real-time updates between client and the server without losing on latency. The protocol itself is quite complicated and involves specific way how to create it, how to make the initial connection, how to send updates over time. But thankfully there are a couple of great third-party solutions and also some solutions provided by Apple for iOS, iPads and so forth, and also for server-side Swift. Before iOS 12, basically only option was using CF Network framework. So CF Network is responsible for sockets, but there is no native WebSocket implementation, sadly. So it's just using C pointers where you can write or read data from. So all this upgrade dance and all that, you need to do it yourself. And luckily, there are a couple of good party dependencies. So like Starscream, Socket Rocket, Socket.io, Swift Websocket. And let's check out Starscream. That's the library where I am one of the maintainers. A library is written fully in Swift language, and it conforms to this WebSocket standard protocol RFC 6455. It's open source in GitHub, so you can see what's happening there, what are the issues, and help them maybe solve a couple of those issues as well. And let's see some code how we can use WebSockets using Starscream. So first, we need to create URL object. Then we are creating the request, and then we're creating the WebSocket object, which comes from Starscream using the request we created before. Then we need to set the delegate. So delegate means that when we receive some events, where we are receiving those. And then in the end, we are connecting to the socket. And let's see how the delegate works. So there's one function you need to implement, did receive event. So in this function, you are receiving event, and then you can see what this event is. Either you have connected or you have received text, data, connection has been closed, ping pong, and so forth. And when we want to send data, we're just calling write method. And in this case, we're sending hello string. And in the closure, we can see that everything is fine. And to keep connection alive, we can respond to pong with ping and also send ping ourselves. And once we're done with the connection, we just call disconnect function and we specify the close code. And close code, it's quite important to specify, because then the server folks, they know what has happened, what maybe there has been an issue, or we want to close the connection normally. And starting with iPadOS and tvOS and so on 13 and newest macOS versions, Apple provides us multiple ways how we can use WebSocket connections, how we can create it. So first one I want to mention is Network.framework. So it's built by Apple and it's quite low-level framework. But when you need this flexibility, then you can use it. And there are components both for client and server support. So let's see how we can use Network.framework in code. So at first we're creating connection using the host, HTTPS and TLS. Then on the queue, we are starting the connection. So we're opening the socket. And once we want to send something, we're just encoding to the data. So hello, we're encoding the data and sending over using send method. And we have completion closure, where you can see that everything has been processed correctly. And to receive data, there are two options. So first one is that we are receiving message. So we can see that if it's final message, and in the closure, we can process it. Or we have more granular way, where you can specify what's the minimum and maximum length we want to receive. And once we're done, we're just canceling the connection, and that's it. Last WWDC 2019, I had a chance to be part of the keynote. And in one of the slides, where they throw all the new technologies, apart from SwiftUI, Catalyst, Combine, and so forth, I saw URLSession Websocket task. And I had some small information from Guy Rambo, who whispered in my ear in one of the iOS conference that it's coming also for watchOS. So I got really excited about that. And it's available only for iOS 13 and up, and latest macOS versions. And let's see how we can use it in the code, how we can create WebSocket using URLSession Websocket task. So first we need to use the session. So here we're using the default one, then URL where we are connecting to, and then we're creating the WebSocket task itself and calling resume in the end, so we are connecting to the WebSocket. So it's pretty similar with other URL session tasks, like downloading something from network. And when we want to send, then we are calling send method and specifying what we want to send, either it's string or data. In this case, we are sending hello string. And in the closure, we have flexibility to see if everything is fine. And when we want to receive, then we are using receive method, and inside the closure, we get the result type, which has type of message. And there we can see if it's data or text. And keeping the connection alive, we can send ping and see if everything's fine with that as well. And then in the end, when we don't need the connection anymore, we just cancel the connection and specify the close code. In this case, it's going away, and also a reason. So a reason, it's more descriptive information, what has happened. So if there are some issues, we can just provide that information to the backend so they can log out and explore in the future. And let's quickly check what are the possibilities on the server side with Swift. And there are quite many ways and really nice frameworks. So first one is SwiftNIO. SwiftNIO is a framework which is built by Apple. It's cross-platform framework. And here it means that it's for macOS and Linux. And it's asynchronous. And using this event-driven approach, so we can process these events in loops. And NIO WebSocket is one component of SwiftNIO. So using this component, we can create servers and clients for WebSockets. And it's based on event loops, and it's quite low level on the framework, so you can have full flexibility if you really need so. The next one is really interesting project by Apple, NIO Transport Services. So a lot of people actually don't know about it, but what it is, it's SwiftNIO for Apple platforms. So it means that it's based on network framework, so you can have SwiftNIO capabilities on iPhones, iPads, tvOS, and it's on the low level side, similar like SwiftNIO framework. And next one I want to mention is Vapor, which is community-based server-side Swift framework, and it's on top of SwiftNIO framework, and it's written fully in Swift language. And what's important during this talk, it's very, very modular. And one of those modules is called WebSocket Kit. And that's the component creating the client and server. And it's on SwiftNIO, built on top of SwiftNIO. And it's in medium level, I would say. So it's not so level, but it has higher abstraction. And let's see how we can use it in the code. So first we need to create event loop group, then specify the port, make the promise where we can receive these events, and then connecting to the actual WebSocket, so providing the URL. And inside the closure, we can describe what kind of events we want to trigger and how to react to those. So once we connect, we send hello. And when we receive something, then we're just printing to the console. And then in the end, we're just keeping the connection alive. And now let's see how we can create server. So at first, we need to create the upgrade pipeline. So it means that we need to describe how the server is being created when the client requests to upgrade to the WebSocket connection. So inside there, we're connecting the server and describing these events when client triggers something or either we want to send. So in this case, on text, we're just reversing the string and sending back And when it's closed, we're just printing out to the console, or we receive data. And how we put that together? Similarly, like with client, we're creating an event loop group, specifying the port, making the promise, and then putting everything together. So all this chunk of code, what it does is just describing how the server is created, and when the client connects, what we are doing. And what we are doing, we described in the upgrade, server upgrade pipeline. And then we're keeping everything alive. And now I want to talk the Vapor framework itself. So that's the highest abstraction. And that's the gluing all this WebSocket module and other parts of the framework together in this Vapor WebSocket web framework. So let's see how we can use create WebSocket client using this approach. So we want to create the WebSocket. We're using WebSocket object and calling connect and specifying the URL inside there. Similar like in previous examples, we're describing what we want to do when we receive text. So we're printing to console, and when we have connected, we just send hello. And how we can create server. So we are doing that in routes function. So that's the function where we specify what kind of routes when we call, what are we doing. So on route path, we're creating the WebSocket server, and now we need to just describe what are we doing. So when someone has connected, we just send everything's fine, you have been connected to the WebSocket server, or when we receive the text, we're reversing it and sending back, and when we are closing, just printing out to console. And when I posted in Twitter that I'm talking about WebSockets in UIKonf, someone asked me if I'm going to share how to create server on the iPhone. So there are a couple of ways. So first one is Starscream. So Starscream has component also for server, not only for client. Next one is SwiftNIO transport services, and then network framework. So there are a couple of ways how to do it. And now I want to mention about GraphQL. So GraphQL, one of the hidden gem is GraphQL subscriptions. So it means that you can subscribe to just like tiny bits of updates from the server. So let's say you want to be notified when user changes username, for instance, and you can subscribe only to that part. And there is a library called Apollo iOS SDK, which is Swift library for GraphQL, and it's very well maintained by Ellen Shapiro, who is well-known conference speaker and voice in our community. And I have been helping out here and there with WebSockets part for GraphQL, this Apollo SDK. But now let's have a dream. How about if you would have Xcode on our iPhones? So I built a concept combining solutions from Marcin Krzyżanowski and Paul Hodson. And Marcin built a cool tool called Online Swift Backgrounds, where you can run Swift code on any web capable device. And it is using WebSockets under the hood. And now let's go to the demo. So here I have project opened. and we'll check out two ways how we can do it. So first one will be using Starscream. So I have the project, there are many files, but the most important are these two files. So the WebSocket Manager delegate, how we are communicating from UI to the actual WebSocket, and then the WebSocket Manager, where you're hiding away the WebSocket implementation. So firstly, we are importing Starscream. Then this is the Starscream WebSocket object, initializing it, and then connecting. So we are specifying the URL, creating the WebSocket itself, and setting the delegate so we can get these events. And opening the connection. And when we want to send something, we're just writing to the WebSocket. And here we have the delegate method. So when we are receiving WebSocket event, when we are connecting, we have connected, we are letting know the UI. And when we are receiving text, we're just decoding and updating the UI. So let's try to run the project and let's see how does it work. So we have here, so hello UIKonf. If we have something like that, we have error, and let a equals 5 plus 5, print a. Seems working. And now let me switch to the URLSession Websocket task. And now we don't have anymore the Starscream, so we're just using tools provided by Apple. So again, everything is same, we're just hiding away in WebSocket Manager the actual implementation. So the WebSocket task is URLSession Websocket task, and we're creating it here. So first we need the queue we're working in, then creating the session, so we can set the delegate to self. So we need to know when we have connected. And then we're creating the actual WebSocket task. So providing their URL and calling resume. So it's similar like with other WebSocket URLSession tasks. And we want to send something, which calling send method and string type of text what we want to compile. And we want to receive message, we have receive message function, and we receive the message from the WebSocket and checking if it's success, then decoding it and updating the UI. But here it's very, very important that why we are calling receive message again. The same message, same function. So it means that when this receive has been called, it doesn't call again, like it doesn't trigger it again. So we need to initiate receiving messages from the socket again once we receive a message. And let's see how this is running, if everything's fine. Let's see, make an error, have an error, let a equals 6 plus 6, print a. Seems working. So now let's go back to our slides. So we checked how we can implement WebSockets using Starscream and also URLSession Websocket task. And everything, all this small project, I have open sourced in my GitHub profile. But let's talk about tools. So WebSockets, when working with WebSockets, it's quite tricky. So there should be a great tools for our disposal in our tool belt. And there are a couple of ones. First one I want to mention is Charles Proxy. So it's really very good tool to explore WebSockets, what's underneath, and see every messages we send, and even decrypt them. Then there is one nice tool, Proxyman. So I would call it new kid on the block. So it's similar like Charles Proxy, also a really nice tool. And then there is Cleora app, which is on iPad. So you can use this app on your iPads, exploring WebSockets and also regular HTTP requests. And in the end, there are dozens of command line tools, and me personally I like the most WebSocket, but there are many more. And let's talk about pros and cons in the end. Just let's look back what we have talked about. So starting with pros. So WebSockets allow us to maintain real-time updates with less network latency. And it means that our apps are faster because we are not sending cookies and headers all the time. And now it's fully supported by Apple as first-class citizen, but there is small asterisk, which means that it's only from iOS 13 and up. And now a couple of downsides. Before iOS 13, if you still support it, it can be quite buggy because of this CF network framework. And when you have these issues, it's really hard to debug because we don't own that code, so we don't know what's happening. Long polling actually can be more stable and more reliable as WebSockets, because when actually we close the connection, the HTTP connection, we know it. So with WebSockets, if we haven't received some messages, we don't particularly know. So we need to have another agreement or like count how many messages we have received or sent, and then other side informs that it has received it. And it's really tricky to debug, but a couple of tools help out there. And closing connection, WebSocket connection is really important, very important task. And a lot of nasty issues can happen if you don't do it correctly. And in the end, I want to mention that together with my beloved wife, we built a tool, SwiftWebsockets.com. So it's a small application, a small website where you can go and check out how you can get started with WebSockets on iOS 13 and up. And there is a small playground where you can download it and play around with WebSockets on your device. And thank you for your attention, and I will be available for your questions after this talk, or reach me out in Twitter. And here's a link to my website where I blog every month about what I'm working on. And thanks.